In this recording, we're going to learn about rectangular and polar conversion formulas. So in other words, be able to go back and forth between the xy plane and the polar graphing plane. So the first thing is, let's refamiliarize ourselves with this circle. Okay, this is like a unit circle, except we're going to say it has a radius of r instead of just 1. So go ahead and graph something like this. And we can do this right on our notebook paper. So give you a moment to sketch that out. We'll label x and y. Okay, hopefully you paused the recording, got this all sketched out. You got your unit, well, it's not a unit circle, but a circle centered on the origin with an inscribed triangle here, with an angle here we're going to call theta. Okay, and of course this is r, our hypotenuse. And then the point here would be the point x comma y. So the height of the triangle would be y, right? And the width of the triangle we're going to call x. So then, how can we describe the angle theta in terms of y and r? Well, just let's have a little scratch work over here. We would say something like the sine of theta, right? Sine of theta, opposite over hypotenuse, so y over r. Cosine of theta, x over r, right? So we've got our adjacent over hypotenuse. So that should be familiar territory. Well, if I multiply both sides by r to undo the fraction, now I've got a brand new equation in terms of, with y in terms of r and theta. And I can do the same thing here. So divide up. So I've got a little equation, x equals r cosine theta. So let's jot those down over here. So we've got x equals r cosine theta. But I wanted you to see where that came from. It came from known quantities, stuff you've been familiar with, you just may have forgotten. And we can describe y as r sine theta. Okay, cool. How about this circle? Well, this circle is centered at the origin, and it has a radius of r, so couldn't I say it's x squared plus y squared equals r squared, right? It's x minus 0, so I don't have to write that squared, plus y minus 0 squared equals r squared. Well, I can do a little work here. I can square root both sides, and I'll have an equation with r in terms of x and y. Okay, and of course we'd have the absolute value, but we're not going to have negative values of the radius in this case. So let's talk about r as the square root of x squared plus y squared. You can kind of see how things are coming together here, right? We're trying to connect our rectangular coordinates, the x and y, with our polar. So the r comes from x squared plus y squared, square rooted. The individual x and y's I can get if I know r and theta. And finally, how do I get theta? Well, let's figure that out. How is theta related to the x and the y? Well, let's do a little scratch work over here. Theta, let's think about a trig function that would relate y and x. Of course, that would be tangent, right? So tan of theta equals y over x, our opposite over adjacent. And of course, if I wanted to get theta by itself, I'd have to do the arctangent, right? Or the inverse tangent. Okay, so if I know x and y, it turns out I can find theta and I can find r. If I know r and theta, I can find x and I can find y. All right, so those are our 4 conversion formulas that we've derived for ourselves. We do want to make a little note about the theta, however. So if x is positive, okay, then we're obviously speaking about an angle in quadrant 1 or 4. So if x is negative, theta's got to be in the 2nd or 3rd quadrant, right, because we're over here. However, you may need to add 180 degrees to the angle, okay? And we'll see this come up in our example. All right, so that's our background. Now let's dive in and try a couple examples. So let's find the rectangular coordinates of this polar point 4, 135 degrees. So first off, we're going to show how to use the formulas. All right, we're going to want to find the x of the point. Well, let's go back and find out what we do for x. So x has to do with the cosine. So we're going to do r times the cosine of the theta. So we have the r and the theta. Okay, well, we can evaluate that. And in this case, now the cosine of 135 degrees turns out to be negative, right? Because it's over this way. And our reference angle would be 45 degrees. And our sides on a 45-45 triangle are square root 2 over 2, our legs. So the 4 and the 2 divide out, divide to 2, and so we'd have negative 2 square root of 2. That's what x is. Now let's find out what y is. Use a different color here. So y has to do with r times the sine of theta, right? So y, similarly, the sine of 135. Now, will that be positive or negative? Let's check out our diagram. So 135 would be like over here. Y would be positive, right? It's up. Again, reference angle of 45 degrees, you would have square root 2 over 2 as the length of y. Positive this time. 4 and 2 divide to 2. Y is 2 root 2. So we have the point for the rectangular coordinate as x of negative 2 root 2, y of 2 root 2. All right, so we're going to draw a little line down our paper here, and we're going to show you how to do it with the calculator, because you can also get a good check from using your calculator's polar graphing coordinate features, so conversion features. So using calculator. I'm going to show you some screenshots here, and hopefully you can make some notes about the menu that you'll want to use. And by the way, the note we made up here about adding 180 to the angle, that's not necessary if you are using the calculator. All right, so if you're using the angle menu's features. So using your calculator, let's make sure we're in degree mode. So we'll check that. All right, so we're in degree mode. Now we're going to use a menu that we haven't used very often, the angle menu. Okay, so second, and then the apps button to get to the angle menu. And we're going from polar coordinates into rectangular coordinates. So we want polar to rectangular x. So choose choice 7. And we will put in the polar coordinates. So 4, 135 degrees. And this is going to produce the x value. All right, need to grow that a little bit. And then one more time we're going to do second apps. And now we're going to choose choice 8 because we want to go from polar to rectangular y. It's going to tell me the y coordinate. So 4, 135. And now it's going to tell me the y coordinate. Now if you're wondering, well, is this the same as what we had? Well, let's check. 2 times the square root of 2. Well, sure enough. And there's the negative square root of 2, and there's the positive square root of 2. Okay, so I'm going to paste here. And what I'd like you to do is take some notes for yourself about where we got these keystrokes under the angle menu, and then how to go about doing that. Okay, so again, these are the same values right here. And with the calculator, we would say it's negative 2.83, comma 2.83. Now that's all well and good, but let's confirm with a quick sketch. So grab a piece of polar paper and let's just see where 4, 135 would be. So I'm going to go out to 1, 2, 3, 4. I'm going to go around to 135 and go out to the 4, so that's going to be right here. Now if I go straight down with a line here, grab my line tool, and I'm going to go straight down from there, and I'm going to go straight across from there. Okay, yeah, that seems reasonable. I mean, my sketch is a little imperfect, but you can see that the x value is about negative, just under -3, and the y value is just under -3, which is consistent with these coordinates here on the rectangular scale. Okay, so again, we graphed it in polar form, where that point would be, and then the x and y match what it would be if this were like a y-axis and this were an x-axis. Okay, final example is this. We're going to flip it around. We're going to find the polar coordinates of this rectangular point. Okay, so we have to first go back up and see what our conversions were. So we want to find the r and the theta based on the x and the y. So I'll grab those two formulas that we're going to utilize. Okay. So let's first find out the r. So we have an x and a y. Let's do a little algebra. Okay, so pretty nice. R equals 2. Cool. Now let's find out what the theta is. And I'm actually going to move this over here, right here. Slide some of these up a little bit. All right, so we want to use this theta formula, the inverse tan, the arctan of y over x. Okay, and we can go to the calculator and do the inverse tangent here. And it tells us it's -30. Okay. Well, now because x is negative, we know we are in quadrant 2 or 3. So we're going to add 180 to that. So theta is going to be -30 plus 180. Theta equals 150 degrees. So that's all right. So similarly, we're going to use the second, let's clear here. We're going to use second apps to get to the angle menu. Now this time we are going from rectangular to polar, so we want to first find the r, and then we're going to find the theta. So choice 5, you're just going to put in the x and the y, so pop that in. Okay, r is 2. Okay, that's the polar radius. Choice 6 now. Okay, and again, and as we said before, when you use the angle menu, you do not need to add on the 180. It does the figuring for us. Okay, let's grab a screenshot of that and grow that a little bit. So what I'd like you to do is take some notes for yourself about what that set of keystrokes looks like on the calculator. Okay, and some people will call this trig form rather than polar form. Okay, to give something in these coordinates, the r and the theta. So again, the one more time, our final answer over here, I should write this clearly, is 2, 150 degrees. That's our answer, aka trig form. It'll refer to it in some textbooks as trig form or polar form. All right, so finally, let's just check real quick. Let's draw a little sketch and confirm that. So if I wanted to go to, what do we say, 2, 150. So again, it's 1, 2. This is going to be a little small, but we're going to go around to 150 on a radius of 2. Here's we want to confirm that that is right. So I'm going straight down for the x. It looks like it's about a little bigger than 1.5, almost 2 there. And then for our y value, I'm going to come straight horizontal with that. It does look like it is right at 1. So our y value is 1. Our x value is about negative square root of 3. Let's just see what negative square root of 3 is real quick. About 1.73. That looks like it could be 1.73 if this is the x-axis, negative 1.73. Thanks for watching.